Okay, so this time let's put our newfound knowledge about sketching functions that might have other kinds of expressions. Let's see, other kinds of asymptotes, in this case a slanted asymptote, to the test. And I'm going to take this guy, and I'm going to just put this way down here so that I can use this to sketch my graph. All right, so I've got the function f of x equals 2x squared plus 5x plus 3 over x minus 4. First things first, we need to go through and make sure we define the domain. Our domain in this case is wherever the denominator is equal to 4, so that's actually pretty easy. Our domain is going to be the set of all real numbers, set of all real values x, such that x is not equal to 4. And I will note that even if I can factor my numerator, it will not factor in anything that cancels that denominator. And so my vertical asymptote coincides with my domain, and that will be the line x equals 4, which I'll go ahead and I'll sketch that in right here. There we go. So I've got this vertical asymptote at x equals 4. All right, the next thing, I will note that the degree of the numerator is exactly 1 greater than the degree of the denominator. Since that's the case, there is no horizontal asymptote, but we will have to find a slanted asymptote. And we find the slanted asymptote by carrying out division. Now, in this case, we're dividing by something of the form x minus 4, so in fact, we can use a synthetic division to very quickly get that division. It looks like we've got 4, let's see, we're going to have 2, we're going to have 5, we're going to have 3 as our coefficient, so I'm going to bring down my 2, multiply by 4, get 8, add, get 13, multiply by 4, 13 times 4, it's 26 times 2, that is 52, adding, that's going to give me 55. Well, what does that mean to me? That means that my equation for my slant asymptote right here is this equation, y equals 2x plus 13. Boy, that's going to be fun, right? That is the line y equals 2x plus 13, which means that we have a line that's going to pass through the point y equals 13 and have a slope of 2. This graph's not going to cover it. I'm going to have to adjust that in just one moment. So adjusting my graph here, I have a graph that looks like it could possibly handle this thing. Actually, I'm probably going to have to shift this thing up just a little bit more, because here's the point 0, 13, and with a slope of 2, to the right 1, up 2, I'm not quite going to make it. So let me adjust this one more time. Okay, so I'm going to plot my line y equals 2x plus 13. By the way, if you forget, this is actually the function in our rational form of f of x would be equal to 2x plus 13 plus 55 over x minus 4. Okay. So plotting this thing, what's going to happen? Well, the graph will pass through the line, through the y-axis at 0, 13. It has a slope of 2. That means every time I go to the right 1, I go up 2. The right 1, up 2. The right 1, up 2. The right 1, up 2. Well, this is going to be a nice steep slope, nice dashed line right here, just going all the way up. I'm going to have this vertical line that passes way up here. Boy, my line just doesn't quite do it justice. But okay, so we're going to need to get some points. This is why sometimes graphing ahead helps, doesn't. But let's see what happens. All right, so let's try and get some behavior. There is no symmetry. This is not going to be even or odd. But let's determine the behavior near the asymptotes, which means that we should choose some points for this function for values of x. And this time, you know what, let's just choose a few on either side of that vertical asymptote. So I'm going to start at 0 because it's an easy number to get. At x equals 0, y equals negative 3/4. At x equals 1, what happens? Well, that means 2 plus 5 plus 3, which is 10, divided by, let's see, 10 divided by 2 minus 4, that's negative 2, so negative 5. Ooh, that's weird. All right, at 2, what's going to happen? Well, at x equals 2, I'm going to have 2 squared plus 5 times 2, 2 times 2 squared plus 5 times 2 plus 3. So that's 2 times 2 squared, that's 8, plus 5 times 2, that's 10 plus 3. So 18 plus 3, that's 21. And in the denominator, I'm going to have 2 minus 4, which is negative 2. So now I'm going to have 21 over negative 2. That is negative 21 halves, negative 10.5. 3, let's do one more here, right? At 3, well, you get the idea right here. And I'll just get a few more values. Stand by. So after properly adjusting my graph, I find that here's the equation that represents my slanted asymptote. Here's my vertical asymptote. And I will label it again, of course, if I can keep everything straight. Here is my slanted asymptote, my vertical asymptote, my slanted asymptote. And looking at some of these points on here, let's see what's happened. Well, of course, 0, negative 3/4, that's like way down here. Let's see, at 1 we got negative 5. At 2 we got negative 10.5. And it looks kind of like what's going to happen right here is that this graph is going to proceed along this slant asymptote. And at 3 we said we got negative 36, so all the way down here, right? Or actually closer to here, right? This graph just all of a sudden takes a turn and goes down near this vertical asymptote. Well, okay. We should get a similar thing happening right here. And what did we find? Well, at 5, we got 78. At 6, we got 52.5, so probably in here. 7, we found about 45.3, and if I were to keep going, what would happen is that this graph is going to continue down along this path and eventually approach this slanted asymptote. So even if we have a slanted asymptote, we can get a graph that looks kind of like this one in its own way. So this is the way that this is going to look.